in this topic, I want to practice some more problems. So the idea is there are many, many applications of time value of money. Figuring out various payment options, which one is better, which one is worse. Planning for retirement, how much should I put in my account today so I have some money in the future? How much should I deposit every month or every year so I have some money for retirement? Calculating a loan payment, if I borrow money for a car, for a home. Right? What will my monthly mortgage payment be? My monthly car payment be? After I make so many payments, suppose I want to pay off the loan. What will the payoff amount be? Okay. Comparing various interest rates. One bank quotes you a rate compounded quarterly, the other compounded monthly. Which one's the better rate? Choosing a compensation package that has different features with cash flows arriving at different points in time, so on and so forth. And so the goal here is to practice some of the more difficult problems so we can see common solution techniques to these kinds of problems. Okay, so let's jump into the first problem. It says you want to endow a scholarship that pays $10,000 per year forever, with the first scholarship award made 10 years from today. If the rate of return on endowment earnings is 5%, how much would you have to donate today to endow the scholarship? Let's do it in Excel. I'm on the first tab. The information we're given is the scholarship payment per year is $10,000. The first payment is going to come 10 years from today. Okay. And the rate of return, the discount rate or interest rate in our environment is 5%. So endowments, if you endow money today, it's going to grow at 5%. Okay? So let's think about the timing of the cash flows in this problem. So we're standing here at time 0. And what are we told? Starting 10 years from now, okay, we want our endowment to pay off 10K. We want it to do it 11 years from now, 12 years from now, and so on, forever, right? Okay. So the first thing I want to do is recognize that this is a perpetuity. So I can apply the perpetuity formula. Right? What is the perpetuity formula? The present value of a perpetuity. Present value of a perpetuity, where the first cash flow is 1 year from today, is just the cash flow over the discount rate. Okay, that's if the perpetuity isn't growing. If it was growing, we would subtract G from the denominator. Okay, so the first really important part of this problem to figure out is if you apply this perpetuity formula to this stream of cash flows, that is going to give you a value as of time 9, right here, right? Because the perpetuity formula assumes the first cash flow happens 1 period from now. Okay, so what must now be if you apply the perpetuity formula? Time 9. So let's do that. Let's apply our perpetuity formula. Okay, so we take our 10,000, divide by the discount rate, and we get $200,000. Okay, so in order for us to pay scholarship winners $10,000 each year, starting in year 10 and on forever, we need to have $200,000. $200,000 sitting in an account at time 9. Does that make sense? We need $200,000 sitting in an account at time 9 that will feed $10,000 scholarships starting in year 10 and on forever. Okay, but the question is, how much do we need in our account today? So we need $200,000 sitting in the account at time 9. How much do we need sitting in the account at time 0? Well, hopefully some of you are saying in your head, oh, but that's just a single amount. I know how to discount single amounts back to today. I just use my single cash flow formula. So I'm going to use the single cash flow formula to discount $200,000 in year 9 back to year 0. Okay? And so that's the last step of the problem. We're going to take 200,000 and divide by 1 plus our discount rate to the power of 9. Yeah, not 10, 9. Why 9? Because 200,000 is how much we need in year 9. When we applied the perpetuity formula, that gave us a required value in year 9, because the perpetuity formula assumes the first cash flow happens 1 period from now. So how much do we need in the account today? $128,921.78. If we donate that money to the university today, and those endowment dollars grow at 5% forever, we'll be able to fund a $10,000 scholarship starting in year 10 and going on forever. Good. Let's go back to the slides and do the next problem. Assume inflation is 2% APR compounded annually. Which is greater, a real return of 3% APR compounded quarterly, or a nominal return of 5% APR compounded semi-annually? Back to Excel. Next tab. So again, we have the key components to the problem. Inflation, we're told, is 2%. Option 1 has a real return of 3%, compounded 4 times per year. Option 2 has a nominal return of 5%, compounded twice per year. Okay, so hopefully you all are thinking, okay, I know there are going to be 2 important formulas for this problem. So the first formula converts APRs to EARs, and the second converts real rates of return to nominal rates of return. So let me write down both of those. So the EAR formula, the EAR equals 1 plus the APR divided by M to the mth power minus 1, where, remind yourself, M is the number of compounding periods per year. Okay. And then the Fisher equation, 1 plus the nominal rate equals 1 plus the real rate times 1 plus inflation. Okay. So what makes this problem a little difficult is these 2 options are not apples to apples. Okay. What we want to do is convert them both to nominal EARs. If they're both nominal and they're both compounded once per year, right, now we can compare them. They're not in shape for that right now, right? They are both not nominal and compounded once per year. So we need to convert them both to that, and then we'll be able to compare them and see which one is greater. Okay. So let's start with option 1. So step 1 is to convert option 1 to an EAR. Okay. Currently it is a 3% return compounded 4 times per year. Well, what is the equivalent annual rate to that 3% compounded 4 times per year? The EAR. Well, we're going to use our EAR formula. Okay, so let's do that. So equals 1 plus the APR divided by 4 times per year to the power of 4 minus 1. Again, just following the EAR formula. Hit enter. Now we have 3.03%. What is that? Right? It is a real EAR. Okay? It's a real rate of return, right, compounded once per year. A real rate of return compounded once per year. Okay? So the next step then is to convert that real rate of return into a nominal rate of return. We can do that using the Fisher equation, right? The equation below, which will help us convert real returns to nominal returns. So let's do that. What would the nominal return be following the Fisher equation? It would be 1 plus the real return times 1 plus inflation minus 1. 5.09%. So option 1 converted to a nominal EAR is 5.09%. Okay. Option 2 is already a nominal return. Do you agree? It's already a nominal return. Okay. So once I convert it to an EAR, it's not an EAR right now. It's an APR that compounds twice per year. Right? Once I convert it, though, to an EAR, now I have these two options. Again, apples to apples. They're both nominal EARs. Now I can compare them. So that's my last step. Convert option 2 to an EAR. We know the EAR formula. Here it is. So let's do that. So converting option 2 to an EAR says 1 plus the APR, 5%, divided by the number of times compounded per year, 2, to the power 2 minus 1. 5.06%. So what is our conclusion when we juxtapose 5.09% and 5.06%? Option 1 is greater than option 2 when they're both in common terms. They're both nominal EARs. All right, back to the slides for the next problem. Upon graduation, you get a job offer with a firm that knows your favorite car. The firm offers to give you $40,000 in cash towards the purchase of the car or to reimburse you for 5 years of monthly payments if you lease the car. If you buy the car, the price of the car is $66,000. You're short on cash, so if you want to purchase it, you have to borrow at an APR of 12%, compounded monthly, by taking out a 5-year loan with monthly payments. Loan payments are at the end of each month. If you lease the car, the monthly lease payments are $900 for 5 years. The contract stipulates that at the end of the lease, you can either purchase the car for $36,000 or walk away. The lease payments are also due at the end of the month. Assume you know with certainty that you will work for the firm for at least 5 years, and you'll be able to sell the car for $38,000 at the end of the lease term. You can borrow or lend at an annual rate of 12% monthly compounding. So that's going to be our discount rate throughout. A says, ignoring the firm's offer, is it better to buy the car or lease the car if you plan on keeping it for at least 5 years? B, now consider the firm's offer. With the firm's offer, is it better to buy the car or lease the car if you plan on keeping it for at least 5 years? All right, a lot to think about. Let's jump to Excel. Next slide. And we have the primitives of the problem. Let me just repeat them for you. The interest rate throughout this problem is an APR of 12%, compounded 12 times per year. So in your head, you should automatically think, okay, that's 1% per month, right? 1% per month. That APR divided by the number of compounding periods per year. So our discount rate throughout is going to be 1% per month. Okay. The market value of the car in 5 years is $38,000. We were told that. Here are the important variables. If you buy the car, the purchase price is $66,000. Okay. The firm is offering to give you $40,000 towards that. Remember, that's the firm's offer. If you lease the car, the monthly lease payments are $900. You can keep the car after the 5 years of lease payments if you pay $36,000 to the dealership. Okay. You can keep it. The firm's offer in the lease case is to pay for 5 years worth of lease payments. Okay. So remember the first part A says, all right, ignoring the firm's offer, is it better to buy the car or lease the car? This is a standard question. When you walk into a dealership, often you have a choice to either buy the car or lease the car. Hopefully I'm going to convince you this present value framework gives you the toolkit to be able to figure that out. Which one is better? Okay. All right, so first, what is the cost to buy the car and keep the car forever? Now, what I'm going to show you first is it's not going to matter whether you choose to keep the car forever or just keep the car for 5 years. We're going to get the same answer, aka the present value of all the payments to buy the car versus the present value of all the payments to lease the car. That difference is going to be the same regardless of whether we keep it for 5 years or we keep it forever. Okay? So let me first show that to you. Just you may be skeptical, so let me show it to you first. So first, suppose we decide to keep the car forever. Okay? Keep the car forever. What is the cost to buy the car and keep it forever? Well, sit and think about it for a moment. Hopefully, some of you will see, you know what? It's just $66,000. That's the cost to buy the car. Now, a few of you may say, whoa, hold on. I don't have the money. Right? The problem is that I didn't have the money, so I'm going to have to borrow that amount in order to buy the car. Oh, that's true, but the present value of the cash flows is going to be the same. Let me show it to you if you're skeptical. Imagine we bought the money. Sorry, bought the car, okay? But we had to borrow the money. What would our payments be? Well, we would use the PMT function to figure out our monthly payment, right? So we'd say PMT, okay? What is our rate? It's 12% divided by 12, right? 1% per month. N per, the number of periods, 5 years, so that's 12 months per year times 5 years, that's 60, right? 5 years, 60 months. Okay. And how much would we borrow? We'd borrow the full amount, $66,000. So if we decided to buy the car, but we didn't have the money today and we had to borrow all $66,000, hopefully everyone is comfortable. Our monthly payment would be this $1,468.13. But of course, the present value of all the monthly payments, the present value of all the monthly payments is just going to be equals PV, the rate, 12% divided by 12, the number of periods, 12 times 5, the payment amount, what we just found, just gets us back to $66,000. Okay? So regardless of whether we have the money today or we need to finance our purchase, aka we need to borrow to make our purchase, the PV is the same. The cost to buy the car is $66,000 in both cases. Okay? All right, so the cost to buy the car and keep it forever is $66,000. So again, this wasn't important to the problem. It's just an aside, but I wanted to show it to you. Okay? So it doesn't matter whether we finance or we have the money today. In the case of buying the car, the present value of all the payments is $66,000. Okay. How about the cost to lease the car and keep it forever? Okay, what will that be? Well, let's think about it. All right, we're going to lease the car, so that means we're going to have monthly payments of $900 for 5 years, and then at the end of those 5 years, aka 60 months, we need to have a big lump sum payment of $36,000, and then we can walk away with the car, live happily ever after. Okay? So think about how we calculate the present value of that stream. We'd say equals PV. Okay. The rate, again, is 12% divided by 12. That is our monthly discount rate of 1%. Okay. The number of periods that we have to make this $900 payment, how many periods? 60 months. That's 12 months per year times 5 years. Okay. What is our payment size, our PMT? Our payment size is $900. Okay. Now, if you close parentheses here, I will have not included this $36,000. Agree? This $40,459.53 is just the present value of 60 months, $900 per month. Okay? So we want to include this $36,000. Remember I told you there are two optional pieces to the PV function, right? That FV at the very end, which remember I said is a lump sum payment. You can specify to the PV function, all right, suppose I have this annuity, the same amount either per month or per quarter or per year, and then a big lump sum payment at the end. Well, this is exactly the case where we can use the big lump sum payment at the end. In order to buy the car and keep it forever, we need to have a lump sum payment of $36,000 at the end. Okay? So I'm going to include this $36,000. Okay? And remember, the other option, just remind yourself, the other option, if I had another comma and put something else here, remember that other option is whether we have an ordinary annuity or an annuity due. If we wanted to specify an annuity due, aka the first payment is today, right? We would put a 1 here. But we don't have that case, right? This is an ordinary annuity. So we just omit that. Yeah. All right. Hit enter. We get 60,275.72. Because it's nicer to see it positive, remember, so see how this is negative? Remember, this is the sign convention. Remember, this is Excel telling you, all right, if you're going to receive all this money in the future, you have to pay it out today, right? That's the sign convention. Just to make things positive, it's going to be easier to work with, I'm going to do 0 minus it just to flip the sign. You could also use the absolute value function if you prefer that. All right. So what's the difference between buying the car and leasing the car? Leasing is about $5,700 cheaper. Okay. So it's better to lease. Now you might say, well, maybe this difference is just because you're keeping the car forever. Remember, in this situation, I'm assuming keeping the car forever. Okay. Maybe buying is going to be better if we only kept it for 5 years. Not true. Okay, so I'm gonna show you this conclusion is invariant to whether we keep the car forever, keep it for 5 years, 6 years, etc. It's not going to matter. Okay, so let's calculate the cost to buy the car and keep it for exactly 5 years, and then cost to lease the car and keep it for exactly 5 years. And we're going to see this difference is the same. We're going to get the same 57, 24, 28. All right, what would be the cost to buy the car and keep it for only 5 years? Okay, so let's think about it. Well, to buy the car today, the purchase price is $66,000, regardless of whether you finance it or not, right? You borrow or not. We already showed that. Okay, so if I only want to keep it for 5 years, what's going to be true? I'll pay $66,000 today, and then in 5 years, I can sell it for $38,000. Everyone on board with that? Right? Buy it today for 66, sell it in 5 years for 38. That's its market value, right? Market value in 5 years is 38,000. I will have held it for 5 years under the buying option. Okay, so how much would we pay out? Well, we pay out $66,000 today, but we get a little bit of a refund back in 5 years. Do you agree when we sell it? So I'm going to say equals this $66,000, but I get to subtract off the amount I get back in 5 years. Well, that's 5 years. That's not a present value. So we're going to want to take this $38,000 and discount it back to today. Calculate its PV, its present value. Well, this is a single cash flow. We know how to do this. We take the single cash flow and divide by 1 plus R to the n. Right? What's our R? That's the R we've been working with. 12% divided by 12. It is 1% per month. What is our N? How many periods are we discounting back? Well, we have a monthly rate, so we need to discount a number of months. How many months? Again, we've been working with this already. 12 times 5, 60 months. So the cost to buy the car and keep it for 5 years, the present value of all those payments is $45,000 and change. Okay. How about the cost to lease the car and keep it for 5 years? Okay, well, let's think about that. So sort of close your eyes and think about, all right, what's going to happen if we lease the car and just keep it for 5 years? Well, we're going to have to make these $900 monthly lease payments for a period of 60 months. At that point, we can buy the car for 36 and sell it for 38. We can essentially make $2,000. Does that make sense? Right, you definitely want to do that, right? You want to buy it for 36, sell it for 38, because you can, again, make a couple grand at the end. If you just made the monthly lease payments and didn't buy it and then sell it, make that $2,000 at the end, you'd be missing out, right? You wouldn't be optimizing with respect to your cash flows. Okay, you'd be leaving some money on the table. We want to soak up every possible bit of money, right? We want to pay the least amount possible under the leasing scenario. So let's do that. Let's write that out in the PV function. So our discount rate is the same, 12% divided by 12. Our number of periods, 12 times 5, 60 months of lease payments. What is our lease payment? $900. Okay. This next part is a bit of a thinker, so see if this makes sense to you. So the 900 we're specifying in this PV function as positive, okay? So when we sell it at the very end, we're going to receive in $2,000. Do you agree? 36 minus 38, or 38 minus 36. Okay, the difference between the two is 2,000. Okay? Well, if the 900 is what we're paying out, positive, obeying Excel's sign convention, we want that $2,000 lump sum at the end to be negative. That's telling Excel, okay, the payments I'm paying out, positive, is different. The direction of the cash flow is different with the lump sum we're receiving it in. Okay. So this $2,000 we're putting as a lump sum at the end. Again, if we want to fit it all in this PV function, this $2,000 we're putting at the end, you want to assign its sign as negative. Okay? You want to tell Excel it's different than the amount I'm paying out. This $2,000 I'm not paying out, I'm receiving it in. Right? Close parentheses. We get $39,358. Again, this is the sign convention. This is net amount you'd have to pay out. Right? That's why the negative is there. We can flip it to be positive by doing 0 minus. And what do you know? The difference here is the exact same amount. 57, 24, 28. Does everyone see it matches? Okay. This is my proof to you that it doesn't matter. It doesn't matter whether we keep the car forever or we keep it only for 5 years. The difference between buying and leasing is the same. It's invariant to our strategy. Keeping it forever, keeping it for 5 years does not matter. Okay, so given these numbers, in this scenario, it's better to lease. When you walk into a car dealership one day and you're trying to figure out whether it's better to buy or lease, take this present value framework approach and given the numbers in your scenario, figure out which one is better. All right. Part B of the question says, given the firm's offer, which should we take? Which should we take? Should we buy the car or lease the car? Now, because I've already shown you that the answer is invariant to whether we keep it for 5 or keep it forever, I'm just going to compare the cost of buying it and leasing it under the keep forever condition. We could do it under the keep 5 years. Again, it would not matter. Okay. So I'm just going to do it under the keep forever condition. Okay. So let's think about it. Given the firm's offer, what is the cost to buying the car and keeping it forever? What would the cost be? Well, let's remind ourselves what the firm is offering. The firm is offering to give us $40,000 towards the purchase of the car. The purchase of the car is $66,000, we know in present value terms. So hopefully everyone's okay with, all right, the cost to buy the car and keep it forever would be $66,000 minus the $40,000 the firm gives us. We would have to pay out $26,000 today. Or if we finance it, we'd have to finance $26,000 worth. Okay? But the PV would still be $26,000. All right. How about the cost to lease the car and keep it forever? Okay? Remind yourself what the firm is going to do in the leasing scenario. In the leasing scenario, the firm's offer is to make 5 years worth of the lease payments. Okay, so in this scenario, the firm is going to make 5 years worth of lease payments. I'm going to keep the car forever. So hopefully everyone sees the only thing that you're going to have to pay out, because the firm is going to make all the lease payments, is this $36,000 at the end in order to keep the car forever. So all we need to do is take this $36,000 and discount it back to today. Let's do that. 36,000 divided by 1 plus, remember our discount rate, 12% divided by 12. We're going to discount it back. How many periods? 12 times 5. All right. And we get 19,816.19. The difference between the two, the difference between these two is $6,183.81. So indeed, again, it's better to lease. Better to lease under the scenario where the firm is offering either $40,000 towards the purchase or making 5 years worth of lease payments. It's still cheaper to lease. It will cost you $19,816.19 to lease. If you buy, it will cost you $26,000. So if you take the job, you should accept the firm's offer to make those monthly lease payments. All right, back to the slides. Next problem. It's your 35th birthday, and you want to begin saving for retirement. You plan to retire on your 65th birthday and live until your 82nd birthday. A lot of very specific particular planning going on here. It's great. Your retirement account earns 10% per year, and the expected inflation rate is 2% forever. A, what is the stream of nominal payments on your 66th through 82nd birthdays that provides you with $150,000 of consumption annually in terms of purchasing power today? Okay, so what payments could you get for your 66th birthday, 67th birthday, 68th birthday that would give you the same purchasing power as having $150,000 today? Make sense? That's what A is asking. B says, what nominal balance is needed in your retirement account on your 65th birthday to provide the cash flow stream in A? Okay. And then finally, what constant nominal amount would you have to deposit on each of your 36th through 65th birthdays? You can count them on your fingers or just quickly, including 36 and 65. That's 30 deposits total to ensure that the balance is the amount in B on your 65th birthday. All right, let's tackle this in Excel. So this is the next tab. Okay. And you can see I've put in the inputs to the problem, and I've already got us going a little bit. So let's remind ourselves of the key components to the problem. Your age today is 35. You'd like to retire at 65. You plan on living until 82. Again, very specific there. Inflation is 2% per year, and the rate you can earn on your investments, this is going to be our discount rate, this is going to be the rate at which we move money forwards and backwards through time, is 10%. Okay? All right. So the first question says, all right, what is the stream of nominal dollars you need at your 66th birthday, your 67th birthday, 68th birthday, so that it would be as if you had $150,000 in terms of purchasing power today? Okay. So hopefully it makes sense. If there's inflation through time, you're going to need more money at your 66th birthday, 67th, 68th. So it would be as if you had $150,000 in purchasing power today. How exactly would we figure that out? Well, I have it here. I have it here in the Excel sheet for you. But let's walk through it. So we do what? We'd say, all right, we take this $150,000. That's how much we'd start with. I'm going to freeze it with my dollar signs because I'm going to fill across and I don't want it to go anywhere. All right, and I messed up a dollar sign there. Dollar sign, there we go. All right, times, so we start with the $150,000. All right, $150,000 with 2% inflation is how many nominal dollars in year 66? Well, we'd start with the $150,000 and then we'd multiply it by 1 plus this rate of inflation, which again, I don't want to move, so I'm gonna interlace it with dollar signs as well. So we take 150,000 times 1 plus the inflation rate, and I need to grow that 150,000 by how many years? Well, the difference between year 66 and year 35, that's today, right? That's 150,000 today. Today I'm 35. All right, so 66 minus 35. So I say 66, which when I fill across, I do want to change to 67, to 68, 69. So I say 66 minus the 35, which I do not want to change as I fill across. So I'm going to freeze that with some dollar signs. Okay, close parentheses. And I get this 277138. Now when I grab this bottom right corner and fill across all the way to my 82nd birthday, right? The numbers over here change, but that original 150,000, the rate of inflation, and my the starting point, year 35, does not. Okay. All right. So let's go back to the beginning. So this gives me right here. This is that nominal stream. That the question is asking for in part A. This is the stream of nominal cash flows that would be that I'd be able to buy as much stuff as if I had $150,000 today. Right? It gives me the same amount of purchasing power. Make sense? All right, so this is the nominal stream. Good. The second question says, all right, given that nominal stream, how much do you need to have in the bank account at year 65, right, to produce this nominal stream? Okay. Well, that means we need to take each of these nominal amounts and discount by our nominal discount rate to get a value at year 65. We need to discount each of these. So year 66, year 67, 68, all these cash flows here need to be discounted back to year 65. So the 66 cash flow here needs to be discounted back 1 year. The 67 cash flow needs to be discounted back 2 years. The 68 needs to be discounted back 3 years, right? Right? We need to discount each of these back to year 65. Okay? All right. So let's do that. So I got us started here. So here's the year 66 nominal cash flow. And here I'm discounting it back 1 period, right? Because 1 period is the difference between 66 and my retirement at 65. How am I doing this? Let me just write it out for you. I start with this nominal amount here. I'm going to use the single cash flow formula for discounting. So I take that future value, I want to bring it back 1 period, so I'm going to divide it by 1 plus the discount rate, which is 10%. Again, we're going to freeze it with our dollar signs. to I want to discount it back one period, but where is this one coming from formulaically? It's the difference between 66 and 65. Now, when I fill across, I want the 65 to remain frozen so that, when I fill across to year 67, the difference will be 2 years. To 68, it'll be 3 years, on and on. All right? Fill all the way across. And so, for example, this $380,451.53, which is what I need in year 82, when I discount it back to year 65, it's 75,000 and change. Okay. All right, so those are my individual PVs at retirement year 65. Okay. So then the amount I need in the account at year 65 is just the sum of all those PVs. Close parentheses. And that number is about 2.5 million. Let me make this a little bigger so we can see it. 2.5 million. Okay. So I need $2.5 million in an account at year 65 in order to throw off exactly this stream of nominal payments if that amount in the account is growing at 10% per year. Good. All right, 2.5 is how much I need at year 65. What would be the amount I need today? What's the present value of this year 65 amount? Okay. Well, that's very simple. If I want something standing, again, think about an amount. Think of the timeline. Here's year 65. Here's the 2.5 million-ish I need. And I want to know what is its present value. I just discount it back 30 periods to get its value today at year 35, right? That's just a single cash flow present value. It's just a single cash flow present value formula. So I would say 2.5 million divided by 1 plus the discount rate. How many periods am I discounting back? Hopefully it makes sense. It's the difference between time 65 and time 35, right, which is 30. But formulaically, I'm showing you it here. You get $143,000. So if I put $143,000 in the account today, it would grow to be exactly that 2.5 million I need at year 65. But I'm not putting $143,000 in an account today. I'm making yearly deposits, right? This was part C of the question. How much would my annual deposit need to be so that I have $2.5 million at year 65, which is the same thing as $143,000 today? Well, when we're making, think about, it's asking, and what is that identical amount I'm putting in the account? Birthday 36, birthday 37, birthday 38, all the way through birthday 65, that is an annuity, and we're looking for the cash flow part of the annuity. Remember, that is the PMT function, PMT. So we say equals PMT, our discount rate, the number of periods, remember, 65 minus 35, that's how many payments you're going to be making or deposits you're going to be putting in the account. And we have two choices here. We can either specify the PV, which we know is 143,531.14, close parentheses, and we now know the annual amount we need to deposit is about $15,000 and change. Or we could have specified this FV, or future value, of 2.5 million. Let me show you that. So we say equals PMT, the discount rate, the number of periods, 65 minus 35. When we get to the PV part of the formula, we put 0, essentially nothing, but for the FV part, we put the 2.5 million. You get the identical answer, okay? I just want to show you two paths to the same number, but the conclusion is in order to have the 2.5 million I need at year 65 to throw off, aka create this nominal stream of cash flows, which again gives me the purchasing power as if I had $150,000 today. In order to do that, I need to make deposits of $15,000 each year, right? With the first deposit coming 1 year from now, which is my 36th birthday. 36th birthday through 65th birthday, inclusive of 36 and 65, is a total of 30 deposits of that $15,225.68. Good. Let's jump back to the slides for our final problem. You are borrowing $500,000 from a bank to buy a house. You will enter into a 30-year loan, which we call a mortgage, with an annual percentage rate, aka an APR, of 6% and monthly payments. So immediately your brain should think, okay, 6% monthly payments. The compounding frequency always matches the payment frequency. So if we have monthly payments, this means this quoted rate is compounded monthly. So 6% compounded monthly is identical to, or what is being communicated is 0.5% per month. That's our rate. 6% divided by 12 per month. Okay. A, what will be the payment size? So if you enter into this mortgage, what will be your monthly payment size? B, after 5 years of making payments, how much do you still owe the bank? Okay. C says, suppose in 5 years the APR drops to 5% and it will cost you $3,000 to refinance at the lower rate. Find the NPV of refinancing. You can assume rates won't change in the future. This is a very common real life example. Interest rates will be moving up and down when you enter into a mortgage at a high rate and it moves to a low rate. You need to figure out whether it makes sense to refinance. We're going to show you can use our present value, future value framework, right? Our time value of money framework to answer that question. Okay. D, if you go ahead with the refinance, what would your new monthly payment be if you refinance into a new 30-year mortgage at the 5% APR? Okay, suppose you go ahead with the refinance, but you don't want to start over again and make 30 years worth of payments. How much could you pay per month so that your refinance loan would be paid off in 25 years? All right, so lots of questions. Let's dive into the problem in Excel. So I'm on the last tab. All right, so the primitives, the inputs to the problem. The loan amount is $500,000. We're given an APR of 6%. The number of years on the loan, 30. Payments per year is 12. Okay, so first question, what would the payment size be? And so hopefully you're getting comfortable with calculating these loan payment sizes. This is the PMT function, aka solving for the CF, the cash flow part of the annuity present value formula. So PMT says, all right, what is your rate? Okay, the rate is the APR of 6%, right, divided by 12. As we said, it's 0.5% each month. Okay. The number of periods, so this loan is a 30-year loan, so we take 30 times 12, 360 months, right? 30 years, 12 months a year, 360 months. Okay. The PV is the amount you need today to go buy your house. How much do you need? That's the amount of the loan, right? That's the amount you're receiving from the bank, $500,000. Close parentheses, your monthly payment is about $3,000, $2,997.75. Okay, good, that's part A. Now, the remaining problem talks about refinancing or paying off the loan after 5 years. So the first thing we need to figure out is after 5 years, how many remaining payments will there be? Well, if you make 5 years worth of payments, remember the total amount of payments, 30 times 12, right? If you make 5 years worth of payments, you're subtracting off 60 of it, right? 5 times 12. So after 5 years, you're going to have 300 months remaining. Okay. All right, so if you wanted to pay off the loan after 60 months of payments, aka when there are 300 months remaining, how much would you owe the bank? Remember this fact. You can always calculate how much you owe the bank on the loan by taking the present value of the remaining payments at the stated interest rate. Okay? So you can always figure out how much you owe the bank by taking the present value of your remaining payments at the contractual stated rate, the rate you're under for that mortgage. Okay? So what would that be? Well, the present value of a remaining set of payments is an annuity present value. So this is the PV function. So we say equals PV. Our stated contractual rate is the 6% divided by 12. Remember, how many payments are remaining? So the N per, the number of periods left, 300. Okay? What is the size of our payment? Just figure that out, 2997.75. So how much do we owe the bank after 5 years? About $465,000. So originally we owed them $500,000. Now after 5 years of payments, we owe them $465,000. Okay. Now notice, again, I want to underscore this as much as I can. Notice we've made 60 payments of about $3,000 each. Quick math in your head, 60 payments, $3,000 each. That's about $180,000 that we've paid the bank. How come we haven't paid down $180,000 of the loan? Because a good chunk of that goes towards interest, right? We've only paid down about $35,000 of the principal. Okay? And again, this is a fact about loans. The early payments that you make, majority of it is going towards interest. The later part of the loan, towards the end of the loan's life, the majority is going towards principal. Okay, so we owe the bank $465,271.78 after 5 years. All right, next part of the problem says, imagine interest rates drop. They drop from 6%, which is, remember, your mortgage, they drop to 5%. Okay? And the question asks, all right, if interest rates drop from 6% to 5%, what is the NPV of refinancing? So what does refinancing mean? What does refinancing mean in principle? What it means is, suppose you had locked in with Wells Fargo, the bank Wells Fargo. Okay, you have this 6% loan with Wells Fargo. Okay? And 5 years later, you look over and Bank of America has a rate of 5%. Okay? Refinancing means you're going to borrow from Bank of America $465,000 and go and pay off Wells Fargo. Done with Wells Fargo. Make sense? And now you're borrowing $465,000 from B of A. Okay? That's what refinancing works, and you're borrowing that $465,000 at a lower rate, 5% compared to the 6% that you had with Wells Fargo. So we want to figure out whether that's a good deal if switching from Wells Fargo to B of A costs some money, and often in refinancing there is some cost. Okay? And suppose that cost is $3,000, okay? The cost to switch banks. So this is the cost. You want to figure out, well, what is the benefit? Right? How much benefit do I get from switching from my old bank, right, at the 6% rate to the new bank at the 5% rate? Well, the way to think about the benefit is in the following. What I want to do is I want to imagine, all right, suppose I had not refinanced. Suppose I had not refinanced. I had just stuck with this payment of $2,997.75 for the remaining 25 years. Suppose I had done that, okay? Suppose I hadn't refinanced. How much would I have overpaid? Let me say that again. Remember, I could have an interest rate of 5%, okay? I could have an interest rate of 5%. If I don't, right, if I don't refinance and I keep on paying about $3,000 a month, how much would I have overpaid? In other words, if I had found a bank, think about it this way. If I had found a bank that was offering me 5% and I had said, okay, bank, I'm going to give you a $3,000 payment for 25 years, for the remaining 300 payments. What is the present value of that? How much is that worth to you? Or said another way, to figure out this overpayment, I'm going to calculate the present value of my remaining payments at this new market rate of interest, 5%. So let's do that. The market rate of interest, 5% divided by 12 times per year. The number of remaining payments is 300. Our payment size is 3,000. Okay. So think about it this way. If when 5 years goes by, the market rate is 5%. If we promise a bank, right, which is now has a 5% rate, I'll pay you $3,000 for the next 25 years. How much will you give me today? What's the present value of that stream? They would say 512,795.71. Okay. But at our existing bank, we're only going to get credit for paying off 465,271.78. Okay. So that is if we stick with our existing bank and write them a check of $3,000 every month for the remaining 25 years, we will have overpaid $47,523.92. We'll have overpaid by this amount. Okay. So this is the cost of continuing with the old bank. Let me just say that again. If we continue to write that old bank checks for $3,000 a month for the remaining 300 months, we would have given them, in present value terms, $47,523.92, too much money. Okay. So this is, by switching from the 6% to the 5%, we avoid this $47,523.92. That's the benefit we get for switching. Okay. What's the cost of switching? It's that $3,000. So that, oh, sorry. We're going to do it in, so the PV of the remaining payments at the market rate is 512,795.71. Therefore, the NPV of the refinance is the difference between these two. That's the benefit of refinancing minus the cost, gets us 44523.92. Good. All right, so is it worth refinancing? Yes, the NPV is positive, big and positive. Okay. That benefit you get of about $47,000 is way bigger than this cost of $3,000. Okay. Now, let's say we do the switch. We switch from Wells Fargo to B of A. What would our new payment size be? Well, remember what we're doing. We're borrowing $465,271 from B of A to go pay off Wells Fargo. Okay, so now we owe B of A $465,271.78 at this new 5% rate. Okay, so what would our payments be? And remember, just so you know, when you refinance, you start over in terms of the number of payments. So you're going to take out a new 30-year mortgage, aka you start over with 360 payments to make. Okay, so what would the payment size be? Well, the payment size would be, so we say equals PMT. The rate is 5% divided by 12. The number of periods, again, because we're starting over in terms of the length of the loan. The length of the loan is going to be a 30-year loan, 12 payments per year. The PV, how much are we borrowing from B of A today in the refinance? How is the remaining amount of our principal? $465,271.78. So the new payment size is going to be $2497.68. Good? All right. Now, some of you may say, oh, what a headache. We got to start over. We made 60 months worth of payments, right? We made 60 months worth of payments, But now we got to start over, and we're going to make 360 months of payments again, right? Before the refinance, we only had 300 months left. After the refinance, now we have 360 months of payments left once we enter into this new contract with B of A. Suppose I just wanted to get this done over 300 months. Well, that's fine. What you would do is you'd enter into the new contract with B of A, but rather than paying them $24.9768 per month, you can pay them more per month. You always, this is a fact, you always have the option of paying more than the required monthly payment. And that additional amount you make per month in payment will go towards principal. You can always do that. Okay. And so the last question says, suppose we wanted to pay this off in 300 months rather than 360 months, how much would we need to pay per month? Well, everything about that last calculation will be the same, except the number of months won't be 360. The number of months will be 300, right? 271993. Okay? So if you make a monthly payment of $2719.93, right, rather than $24.9768, you can pay this sucker off in 300 months rather than 360 months. Okay? Notice, remember, if you stayed with Wells Fargo, you would have had a monthly payment of $2,997.75. Agree? Right? After right, when you do the refinance, $2,997.75 for 300 months. After you do the refinance, if you want to pay things off in 300 months, right, under the refinanced terms, you're only paying $2719.93. So you can see apples to apples, right? You are saving about $280 per month of a monthly payment. Okay? By switching from Wells Fargo to B of A if you want to pay it off in 300 months. Okay. Just to see consistency, let's take this difference between the two. Okay. The difference between the two is about 280, about 280, right? Let's take the present value of that difference. The market rate is 5% divided by 12. The remaining payment's 300. This difference every month is about 278. That's exactly that 47,523.92, which remember was the benefit of refinancing. Remember that? So if we remember, get rid of the cost, that $3,000. This is exactly the benefit of refinancing. That difference in monthly payment discounted back over the 300 remaining payments. Okay. Now, in order to make the NPV of the decision, though, we had to subtract off the cost of $3,000. Okay. So that's got us this 44,523.92. But the benefit of refinancing is this 47,523.92. Again, you can think about that as the difference in monthly payment from the old bank to the new bank. If we kept the number of payments the same, the remaining 300 payments, the present value of that difference is exactly the benefit of refinancing, 47,523.92. Again, this is a great real-life problem. Almost certainly, many of you will have a mortgage and will have an opportunity to refinance. These are precisely the calculations you need to make to figure out whether refinancing is worth it. All right. This was just extra work, so I will delete it. But this is our final answer. If we want to make the payments over 300 months rather than 360 months with the new bank, how much would we pay per month? $2719.93. And that's it. So these were 5 challenging problems. You may want to go back and rewatch the video, but if you fully absorb them, you fully understand them, you have a good, firm foundation of time value of money problems.